மாணவர்களின் சிந்தனைகளை வடிவமைக்க SNS இன்ஸ்டிடியூஷன்ஸ், மாணவர்களின் தனித்திறமைகளை மேம்படுத்த SNS இன்ஸ்டிடியூஷன்ஸ், மாணவர்களின் சாதனைகளை போற்றும் SNS இன்ஸ்டிடியூஷன்ஸ் கோவை.
electric vehicle we are using a different kind of motors. So majorly they are using a BLDC motor, brushless DC motor. So what is the purpose of brushless DC motor means? We are using a permanent magnet in rotor side. For example, in any kind of DC motor we have a stator as well as rotor. Stator side we need to give the power supply. Rotor side also we need to give the power supply. When we are giving the power supply to the stator, we don't want any kind of external devices. So because it is a stationary portion, we can directly supply to the stator. But in rotor side already it is a rotating portion. We need to give the power supply. The power supply will be a stationary, but we need to give it to the rotational movement segments. So when we are supplying the rotor, we need some kind of special instruments that is called as a commutators and then brushes. So the brushes will produce the sparks. So it may give danger to any kind of things. For example, when we are using a battery or some other things, it will make some kind of issues. For example, when we are using a hybrid electric vehicle, we can use the internal combustion engine as well as electric motors. So when the electric motor will produce the major number of sparks, it may cause us very dangerous effects to the internal combustion engines. So in order to avoid that, we are using a BLDC motor, brushless DC motor. That means in stator side they are not changing any kind of peripherals. In rotor side they are changing to the permanent magnet or high powered permanent magnet, right? So that high powered permanent magnet already produces the flux pi1 flux, and then stator side we are producing the electrical flux pi1. So with the help of pi1 flux and then pi2 flux, it will starts to rotate, right? So in a special type of motor, it will be a BLDC. So the BLDC is nothing but brushless DC motor. So this is the control diagram of BLDC motor. So we are using a control segment. It will be a reference speed. So reference speed means we are giving the input. For example, when the driver is giving the input signal. So when we are using internal combustion engine, we are pressing the acceleration. So when we are pressing the acceleration, the fuel injection rate varies. Based on the fuel injection, the speed will get increased. So in likewise in electrical motor, we are using the flux sensors. So when we are pressing the flux sensor, it will give some kind of input. For example, I am giving 500 RPM of speed to the motor. I am giving the input signal 500 RPM. So when we are giving the 500 RPM, starting condition the BLDC motor will give 0 RPM, which is standstill. So it will compare reference speed as well as measured speed. So it will produce plus 500 error signals. So that means it will get 500 minus 0. So it will produce the 500. So based on the 500, we are using the PID controller. So PID controller will give the signal to the hysteresis back controller. Now the hysteresis back controller will do the voltage control segments. Now the voltage control segment will produce the fluxes or pulses. That pulses is nothing but PWM pulses. That will be pulse width modulation techniques. So that means it will give the pulses based on the delay. It will give 600 volt means directly it will repeat 600 volt, but the duration will get varies based on the input signal. Now the BLDC motor starts to rotate. Now the BLDC motor output will give 1, 2, 3, so like this it will get increases. So we are comparing. The reference speed will not change because the user is already pressing the acceleration. The user is giving the signal to the 500 RPM, but the measured speed will get increased from 0, 1, 2, 3 up to 500. So when it will reach the 500, the error signal will get 0. That means 500 minus 500, the output signal will be 0. So when it will be given the 0 signals or a 0 speed, now the hysteresis band will fix. So how much amount of pulses already paid that the same pulses will given to the BLDC motor. When the speed changes, the pulse will also will get raised. So this is called as a closed loop control. So when we are running the BLDC motor, we need a kind of control signals or control segments. So that control elements are like this. So this will be the control elements. So we are using a DSP controllers, right? So in DSP controller, we are using an input signal and an output signal. So we have an internal mode and an external mode. So based on the internal mode, the output is given to the BLDC motor. So this is the BLDC motor, right? So it is a 0.5 watts. That means 500 100 watts
Yes, uncle.
BLDC motor. So we can't control the rotor speed. When the motor is running 1 RPM, we can't stop the rotor. At normal condition, in